Now we will speak about chapter 10, which is aldehydes and ketones. What does that mean by aldehyde? Aldehyde means that we have carbonyl group attached to hydrogen atom, and ketones means that we have carbonyl group attached to two alkyl branch or two aromatic branch. This means that aldehydes must have one hydrogen atom, and ketones, the carbonyl group is in the middle of the chain. Aldehydes and ketones that contain the carbonyl group, which consists of carbon to oxygen double bond. This is carbon to oxygen double bond. Aldehydes have the general formula R C double bond OH. R means that maybe it is H, or carbon means that carbon branch. Yani we mean that in aldehydes must have in their skeleton hydrogen atom. Aldehydes may be referred to by their common names according to IUPAC method. Now let's speak about how can we nomenclature the aldehydes by IUPAC. First, we search about the longest chain which contain carbonyl group, and must be carbonyl group at the end of the chain if we speak about aldehydes. Second step, we remove the letter E from suffix N and put L. Okay, because the aldehyde group is always at the end of the chain, it is automatically become carbon number 1. If we look at the first one, it will be methane, because we have one carbon atom in alkane chain. We remove N, E, and put L, so it is called methanol. And if we look, it is at the end of the chain, or carbon number 1. Here at propanol, this is 1, 2, 3, and this is the carbon number 1, and so on. Substituted aldehydes are named in the usual way by numbering and listing the substituent alphabetically. Look at this chain. Okay, first we have 1, 2, 3, 4, 5, 6, 7, 8. What is this name of 8 carbon atom in alkane chain? It is called octane, but here we called octanol because we have aldehydic group. Carbon number 1 here is the aldehydic group, so we doesn't put number 1. Now we have at number 3 methyl group, at number 4 chloride group, at number 4 methyl group, at number 5 bromide group. If we want to nomenclature as alphabetically, this means that chlor C, methyl M, bromo P. يبقى we will start with the first letter P, so it is called 5 bromo, 3 chloro, 4 methyl octanol. Aromatic aldehydes are usually designed by common names. All the aromatic aldehydes are designed by common names related to benzaldehyde, or sometimes if the aldehydic group beside it hydroxyl group in ortho position like this, it is called salicylaldehyde. Or if we have methoxy group in the para position like this with aldehydic group, it is called anisaldehyde. But if we have usual group like nitro sulfur, it called para nitro benzaldehyde if it is in position para. Aldehydes up to 5 carbon atoms are often called by their common names. What does that mean? Means that from carbon number 1 until carbon number 5 we can nomenclature by their common name, which are related to acid. What does that mean? Here we have 5 carbon atoms, it is called valeric acid. I remove ic acid and put aldehyde. In aldehydic it is called valeraldehyde. Ketones structure and nomenclature. If we look at ketone have the general formula C double bond O and 2 R in between them, where R and R dash must be equal to any carbon chain, not hydrogen atom. IUPAC nomenclature, we name ketones in the usual manner as we say in aldehyde, longest chain which contain carbonyl group, and then we remove suffix E from alkane, the suffix N, and put on, because we talk about ketone. When necessary, the chain is numbered in such a way as to give the lowest possible number to the carbonyl group. What that mean? It is means that when we want to numbering the chain, we must numbering from the side which give me the lowest number to the carbonyl group. If other substituents are present in the chain, they are numbered and listed in the usual way. Okay, look at this compound. This compound we have, this is the longest chain which contain carbonyl group. Now we must numbering the chain. If we numbering from here, it will be 1, 2, 3. But if we start from numbering from here, it will be 1, 2, 3, 4, 5, 6. So 3 or 6? لا, 3 it must be the way that we must, it is this is the way we must numbering the compound. It is called 3, and 8 carbon atom, it is octane, but we remove the suffix e, the letter e from suffix n and put on, it is octanone. And we must put the number of carbon which contain on, it is number 3. And then we have methyl group, we have chloro group, we have phenyl group, which is benzene ring, removed one hydrogen from it. It is C and M and P from Ben. If we want to arrange it alphabetically, we must start by C. C at the position number 5, it is called 5-chloro. M methyl, it is at position number 2, it is called 2-methyl. And phenyl at the carbon number 7, it is called 7-phenyl, and then 3-octanone, the parent name of the compound. Physical properties of aldehydes and ketones, it is the same. We speak about boiling point first. Boiling point, we talk about polar compound because we have C double bond O. Because of the polarity of the carbonyl group, aldehydes and ketones are polar compound. As a result, the boiling point of aldehydes and ketones is higher than alcohol, is higher than alkane with the same carbon atom or with the same skeleton. Now, solubility. What about solubility? Lower aldehydes and ketones soluble in water. Why? Because they can form hydrogen bonding with water. But higher aldehydes and ketones cannot soluble in water because they cannot form hydrogen bonding with water. So the solubility decrease in water rapidly as the number of or as the hydrocarbon portion of the molecule increase. Aldehydes and ketones more than 6 carbon atoms are essentially insoluble in water. Now we prepare aldehyde and ketones. As we take from the previous chapter as example in alcohol, when we take primary alcohol and make oxidization for the primary alcohol, we find that we get aldehyde. Secondary alcohol, we get ketone. But we have missed step here. What is the missed step? That when we make further oxidation to aldehydes, it will give me acid. How can we prevent this step? We can prevent this step by taking precautions must be taken to remove aldehyde from contact with the oxidizing agent as soon as they are formed. When we form the aldehyde, we take it from the medium before it is contact with the oxidizing agent again to give me carboxylic acid. Catalytic oxidation of alcohol for high boiling aldehydes. What does that mean? This reaction, when we speak about this reaction, when we take alcohols, we take alcohols with higher boiling point and we prepare aldehydes with lower boiling point. So the boiling point of the reaction must be less than alcohol boiling point and higher than aldehyde boiling point. But if we have aldehyde with higher boiling point, يبقى we take this reaction. What about this reaction? We take alcohol and raise its temperature to 200 or 300 and then we pass it to the copper. Yani we make oxidation by copper. Copper give me aldehyde and we remove it from the medium before it is contact with the oxidizing agent again to give me acid. Oxidation of alkenes, as we take in the previous chapter of alkenes or in the alkenes chapter, we find that ozonolysis must give me 3 products. 2 aldehydic compound or 2 ketonic compound or 1 aldehyde and 1 ketone compound. So we take also this reaction before. Number 4, hydration of alkynes. When we speak about hydration of alkynes, we find that we have intermediate compound which is called enol. What does that mean by enol? Again, we make a revision. Enols means that we speak about alkene with double bond and all alcohol. So we take in from alkene and ol from alcohol, this is called enol. Enol form is an intermediate compound. Why? Because the presence of oxygen cannot make the double bond between carbon and the carbon. It is possible. It is impossible to make carbon-carbon double bond and we have oxygen. The compound make a rearrangement for itself and give me a double bond between the carbon and the oxygen. So it is transferring from enol form to keto form. Yani maybe it give me aldehyde or ketone. Friedel-Crafts acylation, it is also from the benzene, from the reaction of benzene. Ketones, we take benzene with the acyl compound in presence of aluminium chloride, it will give me ketonic compound. Reduction of acyl chloride, how can, this is special for aldehydes. We take acyl chloride and take hydrogenation and poisoned platinum in presence of bismuth sulfate, it will give me aldehyde. Hydrolysis of geminal dihalide, benzaldehyde and derivatives. Here we take toluene and in presence of chlorination with in UV. What does that mean in UV? Mean in that we make substitution to this hydrogen and put chlorine. In presence of HCl, this means that we substitute also the second hydrogen with chlorine. And this is the arrangement of the compound. What does that mean by geminal dihalides? Let us make a revision. What does that mean by geminal dihalide? Geminal dihalide means that we have two halogen atoms on the same carbon atom. If we take this geminal dihalide in alkali medium and in water, it will give me benzaldehyde. This means that it will turn to C double bond OH. This is the last method of preparing aldehydes and ketones, and it is special for aldehyde and we doesn't take it before. What we do, we take propene in presence of carbon monoxide and hydrogen, and at 200 in presence of catalyst and 250 atmosphere, it will give me aldehyde. This method, oxo process, is a special method for preparing aldehydes. And this all the method of preparing aldehydes, and as you see that most of the method we take it before from the previous chapter, maybe from alcohols, maybe from benzene, maybe from alkene, alkyne, and so on.